computer science major. So this is truly an interdisciplinary type of topic. I met George when he was in my honors book club class, and one day we were talking about chromosomes, and I got into genetic genealogy, and I said, here's a good idea for a project. And by George, he did it. He got it working. It's amazing. I'm really excited about it because I'm big into genetic genealogy. You know, I'll send my DNA off and I get the results back and I try to analyze it. So this all stemmed from one of those stories that went in a class that wasn't even a biology major. So this is melding computer science and biology together, and I'm really pleased with the results.
So I'm going to hopefully show you the program itself that we developed in a second. But first I'm going to give a presentation to tell you about why we need it and what it does. So this is cluster analysis software for genealogical data. Let's see. I guess I should point it that way. So first, genealogy, for those who don't know, is just the study of families and the tracing of lineages. So there's different methods of study for interviews, looking at historical records and documents, and then genetic analysis to get data regarding families and lineages. So why are we focusing on genetic genealogy? So it's a huge business. I think last year there were over 12 million ordered tests, and those are like $50 a piece. So that's a lot of money going in here. You can confirm your connection to a specific ancestor through matches and break down genealogical brick walls. So that's really useful, like say you're adopted and you want to find your birth parents. Records might only show like adoptive family members, but you can look at genetics to trace people that you may have never known were in your family. And it also has applications to forensic science, which, say one of your family members or someone gets arrested or something, or they're not arrested, but like they're a suspect and they have DNA. If it's similar to somebody's in some of these storages of data, then this could be used to help narrow down who the suspect may be. Genetic analysis. So there's a whole bunch of websites that do genetic analysis, like Ancestry, DNA, and 23andMe. There's a whole bunch of them, and what they'll do is they'll let you download like a spreadsheet or a CSV file, some kind of data file, with information about matches, like genetic matches, and all of this data that they've collected from people who submit blood work. The problem with these files is that most companies will only allow you to compare a few individuals at a time, and if you don't know that those individuals are necessarily related to you or to each other, then it doesn't help a whole lot. Some individuals with which you may match may have an overlap, but you can't confirm which side of your family has the common ancestor. And if you find a whole bunch of individuals with the same overlap, and you know that one ancestor is common, then you would have a starting point to look at the matches. But it's hard to do with the data in the format that it's in when you get it. You probably can't see that very well.
Just to dim the lights.
Sure.
Would that help?
It's still not very visible, but that's part of the problem. This is what the data you would get from one of these websites would look like, and it's not very legible. It has the name of the host, the name of the person matching, the chromosome where the genetic match takes place, and then the location and data regarding the match itself. And each one of those lines with data in it is a match. And there's not a whole lot you can do just as a person with this information. It's not very useful. So to go over just a little bit about the data that's in that file, there's autosomal chromosomal sequences. Autosomal test sequence sections of the chromosomes to look for single tandem repeats, which are basically major landmarks in the DNA. And then single nucleotide polymorphisms, which are very small landmarks in the DNA. There are overlapping DNA segments, and the higher the percentage of homology, or how closely related things are, the higher the amount of overlap and the more closely related an individual will be. People who share the same overlaps or your DNA may share a common ancestor to you, to each other. So we had to develop a solution to the problem I mentioned earlier, because all of that data that's in there doesn't make a whole lot of sense and it's not easy to use. So we came up with the idea of cluster analysis. This was what Dr. Blair had been talking to me about when we decided to make this program. It basically takes groups of people who match on the same spot on a chromosome and groups them together in very organized groups that you can look at and see. Say you know one person, say you know this person's your mother or something like that, and you say, okay, I'm going to look for groups that have her in them. And then that way you know that the other people in those groups are more likely to be related to you. So the way this works is basically there's genetic overlaps in certain locations, and I just said that. Before I go into how the program itself works, I just want to give like a brief description of object-oriented programming, because it was kind of crucial in making the program. Basically, object-oriented programming is programming into your program a type of thing, and it will have just giving it general properties that later you can go in and fill in different instances of that kind of thing with specific properties. So for example, you can say, okay, here's a class of object, it's a car. But later on you create, say, a Polo, a Mini, and a Beetle. Each one of those cars has specific properties like gas mileage, shape, fuel capacity, engine, stuff like that. In the case of our program, we have several relevant objects, including matches, people, chromosomes, and most importantly, clusters. The matches have properties that were listed in the file itself that I showed you earlier. People can have properties such as matches that relate to them. Chromosomes can have properties such as clusters that take place on those chromosomes, and people who have matches on those chromosomes, and just matches themselves that take place on those specific chromosomes. And then clusters can have a lot of important properties that are crucial to the program and to all of this organization working, because a cluster has to have the start and any location as properties, as well as the chromosome that it takes place on. And it also needs to have a list of people who fall into that cluster. So what the program does is it reads the information from the file, it creates the objects that I just went over, and it compares their attributes. It compares the matches, it compares the people, and sorts them based on those matches and attributes into clusters. The goal of the program was to be able to parse the information and cluster the individuals together. That is what the program looks like. It's real easier to see. It's going to be in a second, so I'm going to go ahead and point out what the buttons do. There's a button here, browse button, to select your file. This little box here gives you a message regarding the state of your file. When you click parse, it analyzes the file, and then down here in this box you can click which chromosome you'd like to see matches and clusters on, and then click OK to see it in this box here. And if you like the information you see and you think this is what I need to save for whatever reference, you can export your information to a very convenient text file. So here is a sample of the program output. On the left here, it states the chromosome, and then it lists a cluster. So it gives you the location of the cluster, and then it has names with the matching SNPs and the centimorgans. And so you have Bob Jones here, he matches, and then the data regarding his match in this cluster. And here is a text file that would be generated from that. So the results of our program is that we were able to turn this very complicated file into this organized file. And in a normal file, I created this file myself based on a template from another just to protect people's privacy. But there would be hundreds of thousands of lines. And it would be very unreadable. It would be a lot simpler to be able to read that in this format. Make a lot more sense. Possible future additions to the program would be an improved user interface, including a graphical cluster representation. So instead of just seeing a text file, like I said there, it might be a way to make a actual graph, a visual representation of the clusters, which would make it a lot easier to get the information you want. Additional sorting and filtering options, such as if you wanted to narrow out a certain part of your family that you didn't want information regarding, or you already knew about, you could take that out before running the file and not have to see certain clusters. And it would make it easier to find the information you're looking for. And improve compatibility with different DNA services files, because the different websites I mentioned earlier, their files are slightly different. So in the future, hopefully we'll be able to pick a specific website and it will be less prone to errors when looking at the file. So thank you. Now I'm going to show you a run through of the program itself. I would have spent less time on the presentation, but apparently the program is going to look like this today, and it's not very readable because it's tiny. So I can click browse here and go into this tiny window that really hasn't done tiny, and find a sample folder. So here is a test file that I mentioned before. To parse the file, it says in that box there, it says you've successfully picked the files, just because it's not readable, tell you. And you click the parse button that I mentioned earlier. It says that the analysis is complete. I can go down, select chromosome 2, for example, and click OK. And right there is basically the same data that was in the PowerPoint. There's actually a little bit more in this one because it's a bigger file. And I can click export. I already did. I'm not going to do it again because it would just make the same file over again. And the result is this text file. So that is all regarding my program.